G'day guys. Remember me saying that you got to keep on innovating and innovating and innovating to get any really good performance out of these detectors. And when you think you've hit the pinnacle of performance, well, there's more to be gained. You want to check this out. Okay, on the bench. Yeah, it's a little bit of free advertising I'm sticking there at the moment. There you go. Why not? Okay, down there, that is a GPX 4500. I've just finished doing a fair lot of work to it, but this is really amazing. You got to watch this. I might turn it up a little bit just so you can hear it. I hope that's loud enough. I've got a microphone sitting over there near the speaker. If you can see it on top of the battery, that little black fluffy looking thing. So this is in okay, this is in sensitive extra. So basically it's normal timings if you look at the transmit waveform, but probably a little bit quicker on the receive inside the detector. So we'll have a look at this. I'll show you some things, right? That's sitting there humming away quite nicely, and I might have to lift this up a bit so we can get level with the coil. Oh, up we go. Now need 10 hands for this. I'll lock that off, undo that, bend that up there. But just give you an idea, those yellow things are just post-it notes I use for inert testing, where I can get a level and I know it's at that level. So they're neither here nor there. Better take off that ring or else it'll be booming all over the place. So I'll take these off. Okay, this detector is not cranked up. What I actually did, I got a standard 4500 and I matched the sensitivity on this to the exact same amount of noise from the electrical interference as what the standard 4500 was doing. So I matched it to this one. So this one here, the gain's turned down a little bit, but I'll show you something. There's that little, where am I? Hang on, I've got to get around this side of the camera because again, I don't know what I'm looking at. Oh, I'm over there. There we go. That's that little, I don't know if you can see it anyway. 0.0025. I don't even know if you can see it. It's just basically an absolute fly speck. But what we'll do, how good do you think it'll pick it up? About 5 centimeters. That's on sensitive extra. 5 centimeters on that tiny little speck. Like I say, it's just what it is. Well, that's 6 centimeters. 6 centimeters on that. Big question. Will the detector ground balance? We'll try, I've got a number of these hot rocks. We'll try this one first. This is pretty reactive. I'll put the test target up here because otherwise I'll lose it. I'll just give it a quick flick so it goes into fast track. Not a problem tracking that out. We'll try one of these Kalgoorlie Ironstone Specials. These ones, basically, it's more or less solid iron. I'll put the magnet back over there. So this one, we'll see how we go. Give it a quick flick into tracking, fast track. Bye bye. This one. Nice big Bundy hot rock. Quick track. That one, bye bye. So, how about, where did I put that little thing? So even after all that tracking and so forth, that little speck, not a problem. Now, like I say, there's more gain in this. I can turn this up and we still will be able to track out the hot rocks. So let's go. We're running probably around about half gain. So I'll take it, I'll just go all the way up, flat out. We'll see how we go. Now it's going to pick up a lot of interference because in suburbia, but if we want to go over and listen to this, just about overloads the detector. Imagine going over and you just tiny little speck and there's, you wouldn't think that was a tiny speck, would you? You would say, no way. I'm up at 7 centimetres. I can hear it in there. I'm not going to go up to 8. It's getting ridiculous because the noise will just overcome. Will it ground balance at that flat out gain? Let's try it. Okay. Bit of burbly noise there, but it tracks out, not a problem. Try this one. When the detector makes all that horrible noise, it's because I'm putting my hand on it. I haven't got the case on it. It's sitting there. I've just finished it, so I was pretty excited to do a bit of a demo, a bit of a show and tell. This is one of our customers' detectors. I think he's going to be over the moon. Anyway, God, back in the high-speed track. You get some fringing effects, but I think it's just with the noise coming in because we've got a lot of noise. But you know, let's give it a quick flick again. There we go. Big one. Actually, these ones laying outside the coil were actually having an effect, but no big deal. Quick flick. Move these away. Doing an impressive job getting rid of that, I tell you. That is a dirty big, that's probably the most reactive hot rock in my collection of hot rocks. Leaves everything else for dead. That is just an absolute doozy of a hot rock. Now, I'll just turn the gain down. So even on very, I've turned the gain right down to 0, okay? Big question, will it still pick that up? I'll give it a proper swing. Pick it up around about 4.5 or 5. And the detector is basically, you could run that in on anything. I mean, it is just dead quiet as you can hear it. So what a gain range. That is just massive. And even on zero gain, it's completely fully usable, you know, and bigger targets like rings, you know. Yes, it's like no gain. It's basically we're back into negative gain territory, and basically means you can handle any ground you throw at it. The other thing I've done with this as well is because I've done things to be able to tame things down that we can run more gain. And basically by what I've done, we can go into the lower frequencies through the manual tuning, because that's all variable frequency now in this detector, that you can set it up to get little tiny pinpricks if you want. But think going down the lower frequencies and that extended gain range without hot rock, you know, hot rocks overpowering the system, or really hard to ground balance. I'll tell you what, if it ground balances on those, it'll ground balance on anything. But you can run the lower frequencies, you crank it right up, and it should be as quiet as a church mouse, basically, and use a dirty big coil and run extreme gain. Any big gold that's been left behind, you will be able to hear that easy. Other detectors would have walked over it, and well, people using detectors would have walked over it. We should say that. But yeah, this is astronomical. This is unbelievable. Sort of the way this is performing. It's really good. Like I say, if I didn't push the boundaries and keep innovating, this would not exist. It just would be a standard um, upgrade. But this one here is an absolute doozy. Everything has been fine-tuned. The filters have been done in the detector, by the way, which is not an easy feat to do. And yeah, it's going really well, extremely well. And like I say, I'm pushing it in the hardest mode to make work by exposing the detector to all these hot rock things and tiny targets. I mean, that is just amazing. And look, you know what I can do? How about we go and flick this into another mode? How about get down there? I'll flick it straight into normal, right? Not normal enhance, but normal. Okay, so we'll go into normal. Normal, basically, it's in mono using the anti-phase coil, so we get rid of some of the noise. We're in tracking and deep. Everything else on the back menu, except for the frequency, is dead bog standard as you reset it. Everything is nothing has been changed. So now we're in normal mode and we're on the lowest gain, and the detector's just purring beautifully. So what I'll do, I'll spin this back around. So we'll use this tiny little speck of a target again. It is microscopic. I'm going to put the magnifying glasses on to see that. It's right at my thumbnail. Oh no, that's probably too far in. There it is there, right at my thumbnail. We'll go back up here to the coil. Normal mode. Will it pick that up? Yep, not a problem. On basically zero gain. We're into negative gain territory. Four and a half, 5. That's amazing. How about we can try some other modes on the detector? I mean, I can crank that up and it's going to give a much better signal response. But in the suburbia, we do have all that horrible AC interference. But what can we throw it in? How about throwing in enhance? I'll put it in enhance mode. Well, actually, I should have shown the hot rocks. Actually, it eats hot rocks for breakfast in normal mode. It just doesn't care less. So now we're in enhance. So I don't know why it's called enhance, because what does it enhance? I know it doesn't enhance depth. It doesn't enhance. Well, actually, a little bit. Sometimes it can enhance sensitivity to very small gold, but that's with a bog standard detector, not something like this. So anyway, we're on zero gain, and they got that little. It's amazing. They're all coming up to 4.5. How about some hot rocks? I got it in slow tracking, so I better flick it. Now, just flick it again. So there you are. I put 3 dirty, big, rotten hot rocks in there. Doesn't care less. And as you see, hot rocks does not interfere with the signal from the target one little bit. So there's basically nothing being lost. It's just booming. I could go for all the other modes, but it just eats everything for breakfast. This is an absolute doozy. This is I'll tell you a thing about this too. This detector. This is the older. Now make note of this. The older 4500. And if you want to know the difference, I'll say this as an opinion piece, okay? Just so no one gets their nose out of joint. The later 4500s, in my opinion, right, are just built on a 5000 board, and they just had the gain slope or gain of the input stage lowered. There's a few other little tiny things there, but it is basically what it is. These 45s, the older ones, I don't know why. It's like they made a really good detector, then they broke the mold and never made another good one. Well, actually, that's just my opinion. But no, they did make good detectors. I shouldn't say that. But this thing absolutely is a thumper. It absolutely thumps. Could you imagine that? Well, I can. I can imagine it. Having it set up in normal mode, so it's not going to get really have any hot rock problems or hot ground problems because you've got so many adjustments. And you can just put that down into a lower frequency. It basically means you can run a heap more gain. You have a less ground noise because it gets away from ground decay in the lower frequencies. And you can go put a 40-inch or a 60-inch coil on that, and it will just sing. It'll be fine. But even with such a big coil, as the coil edges probably go over even birdshot, it probably still register as a very quick signal as you go over it. And just go blip, or you get a double blip. You don't want to run big coils low frequency and pick up tiny targets. You won't be able to pinpoint them accurately. You'll spend too much time on it. You'll waste your time. When you go looking for big targets, just pay attention to the big targets. And if there's any small stuff, come back with a small coil later on, and it's far more efficient. So that's this detector. Now, I can't show that. Hang on. I'll just zoom this out, out. Silly. I was just trying to get focused and I don't want to show details. But the serial number on this box, this is what I think anyway. Here, have a look here. On the older ones, they all start with 100. Now, that may not be all of them, because they're made in different places, these detectors. But the older one, this one here is a real ripper. It really is. And serial number starts on 100 and then followed by 4 more digits. So, yeah. And yeah, we'll call the owner of this one's name Stu. We'll call him Stu. So Stu, that's your detector. And I'll tell you what, I think you'll be pulling some good gold with this. I really do. I think you'll be cleaning up. But as far as I remember, he does a lot of detecting. So that's that, guys. That's that. Yeah. Like, remember I said I got new parts in? And yeah. And speaking of new parts, oh dear. Speaking of new parts, I think I should save this one for another video, but a very big, large company I bought some parts from. And they're very expensive low noise ICs. And I hooked them up into a detector and it was noisy. And I went, come on, what's going on here? And it actually was severely noisy. So I made up a noise test jig, as you do, right? And I can show you the test jig, wherever it is. It's on the bench here somewhere. Or maybe I've put it somewhere. Oh, no, I know where it is. Okay. I moved it because it has a whole heap of lithium batteries connected to it. When you do noise testing, you don't want to use a mains-based power supply. No way, no, not in any. I'll just turn that off because that's just droning away there for no reason. Oops, I just picked the microphone up and chucked it. Okay. I've been so damn busy that I probably put it somewhere. Oh, I know where I put it. I put it somewhere safe. In here. Okay, come here, you. I might as well show you this little gadget. And you can make these up yourself if you want. They are very, very low noise voltage regulator power supplies. There's one for basically regulates to positive 5 volts. The other one is regulating to negative 5 volts. And to do that, I run 2 sets of lithium batteries. And basically, lithium batteries, you're putting roughly 8 volts on the 5 volt regulator positive, 8 volts negative on the 5 volt negative. So you've got a bit of headroom there to regulate down. And this is one of the lowest noise power supplies you can make for doing op amps. So yeah, there's the batteries. You notice they've got tape around the end. These things go off like bombs if you short them out. You don't want to. But here, you've got to make a ground plane type setup. And what I've actually done here, I've put the IC Well, you can put any IC in there. I just put 2 solder blobs to hold it in. Don't know if you can see that. But you basically, on both inputs, use 0.01% metal film resistors to ground. And on the output, you use 100,000 ohm. That's a metal film. Doesn't have to be accurate there anyway. And run that back to the non-inverting input. And as you can see on this, I've got a little thing sticking up I can put my oscilloscope on. And I've also put an audio jack in there. So what you can do, you set it up and you hook it all up with your device under test. I'm going to make a proper one anyway so I can clip in and clip out devices, because there's so much fake devices out there. You've got to be careful. It can catch you out. You just believe it's genuine from the factory type stuff, and a lot of times it's not. Anything out of China, just about, is absolutely fake. Do not buy ICs out of China. Any low noise spec, or meant to be low noise spec op amps and that, don't buy it of China. You will get ripped off. I've done it just as an experiment, and everything's like a LF353 or something. It's been scrubbed down, they polish it up, and they screen print a different number on it. So you're paying $20 a chip for something worth 10 cents. I'm not joking, there's big dollars in it. And that's what I was saying before about a particular big company sent me a tube of chips, which I paid $990 for, and they are all fake. The whole lot of them are fake. I'm not happy, and I told the manufacturer too. This is the one that got me. I actually told the manufacturer, and the manufacturer just crickets, didn't care less. So, and that's that. The manufacturer doesn't care that their distributor is selling fake chips. I think that's amazing. A big American company, not saying any names at the moment, but I'm going to, because they just ignore you. So, well, the internet's a powerful thing, isn't it? So I might be using that. Yeah, I've got all the documentation. It's 100% truthful. I got fake chips and I can prove it. You can prove it on that actually. Anyway, what you do with the audio jack there is that you look at the basically use the two 10 ohm resistors, because the noise from 10 ohm resistors is nothing. Basically, it doesn't generate any noise. Resistors make noise. The higher the value, the more noise. So you got a reference there, and the noise above what you would expect out of that circuit is noise generated by the IC, which is mounted on that board there. So you can put any type of chip in there, and if you really want to listen to it, you can plug headphones in and listen to the noise out of the chip. It's just basically white noise. And you can, by putting different boards in and stuff, you can listen to it. It's interesting with a lot of these ICs, they all have different tonal qualities. So, yeah, so that's what I knocked up as a quick chip tester. It basically tests the thing from DC to daylight as far as the thing will go. And you can just listen to the noise, just the basic noise floor of the IC. So I put on some, nice chips. I've actually tried AD797s, which is like in all the MindLab detectors standard, and you can slightly detect the noise. I actually hooked up one of my, banks of devices I use in my own front end design. Can't hear a damn thing. And I put this super special 0.75 nanovolt per hertz bloody whiz bang op amp on there, and I was expecting around about 2 millivolts of noise after amplification, and it came up at 40. I went, bastards, that's ridiculous. So what have they repackaged and sold me? They've gone out of their ISO 9001 trackability or traceability and gone and bought something off someone somewhere in the marketplace it's fakes, and it's a real letdown. If I said the name of the company, they'll probably go completely berserk, but they deserve to go completely berserk because it's 100% truthful what I'm saying. 100%. I'm just going to present the facts, but I'll do it in another video, and we'll see what happens. See if they ignore me then. I can't believe it. You know, ridiculous. Anyway, enough of that. So anyway, that's the 4500. It's come up a treat. And what I'm going to do now is what I've done to the 5000, which is work. The 5000s are working really, 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 really well. But I'm going to try and shoehorn the new design up of what I've done to this into a 5000. The thing is, will it work? This is the thing. 5000s tend to be finicky. They just are. They're finicky. You've got to change a lot of stuff on a 5000 to make it work properly. So, but we probably can. I think it's called perseverance, and just test, and away we go. So, yeah, that's probably enough waffle. Half an hour's enough waffle on this thing. So, just let you know that we're kicking ass with all this stuff. Like I say, I am impressed. It's very hard for me to impress myself, but I am impressed. So, God, every time, you put more time in, you try this, you try that, go a different way, different angle, from all the knowledge you've picked up over all the years of doing this sort of stuff, and other stuff as well, which actually plays in. A lot of my RF stuff from years and years ago comes and plays into this. You can look at this stuff and you can treat it like audio. You could just say, oh yeah, just make it like an audio preamplifier, and the rest of it, yeah, it's audio frequencies. Won't work. It's quite interesting. You got to know so much about it that you can make the most beautiful detector. You take it out and it'll be a complete pig of a thing. It either will not be smooth, it won't detect, or it will just do something completely, left field. You just wouldn't have taken into account. But 99% of getting the field work right for detecting is done on the workbench. Believe me, you can simulate just about everything. The only thing I can't simulate is probably a solar storm, an aeroplane going over with transponder radar affecting, and running a 20-inch mono in the room. Now, I can't simulate that. Well, I could, but it's pointless. You got to use it out in the field. But there's a lot of stuff you can take away from this, and just know damn well that's going to work on that, because a lot of stuff's much of a muchness. But even just dealing with the 50 hertz or harmonics thereof, cable internet, and all the other noise sources, we can squash all that out. So you squash it out here, squash it out in the field. There won't be any in the field. So super quiet, super punchy, and oh dear me, yeah. I think I broke the mold on that one. I'll tell you. No, it's really good. It really is. I'm pretty happy about that. So yeah, enough waffle. I'm going to get put that back together for stew, and yeah, I've got another one. I'm just going to finish off too, and that's for, yeah. I don't know how I'm going to say that name because it'll everyone know who it is. Anyway, I'm not going to say. Anyway, catches.